So the first thing we're going to look at today with our new unit is called expanding binomials. Okay, so it doesn't only have to deal with quadratics, with the expanding. Expanding can be for any binomials. Okay, let's just define a couple of terms here. What does the word binomial mean? Two terms. Bi means two terms. Okay, so basically what I'm doing here and what does the word expand mean? Make it bigger, right? Okay, so in this case, expanding binomials is I'm going to make it bigger, okay? So what I have here is I have two binomials. So the first bracket has two, right? And the second bracket has two terms. What's happening between the two brackets? What kind of operation do I have between the two brackets? Multiplication. So I have to multiply, right? Multiply the two binomials. That's what expanding means. There is multiple ways of expanding the binomials, okay? I'm going to show you all different ways, but in class I'll be only doing one of them, okay? Which is, I think, it's the last one, okay? So I'll show you all the different ways, but in class I'll be just performing the last one always. So first thing, let's look at a video on how to expand binomials using algebra tile and algebra models. We don't have algebra tiles here, but if you feel like this is going to help you, you can make your own. Okay, but a lot of other schools, they do have the algebra tile and they use them. But here is a video on how you can use algebra tiles.
And the small yellow square represents positive 1. When we turn them over to its red side, it represents its negative component. Negative x squared for the large red square, the long red bar negative x, and the small red square is negative 1. When we do not have color tiles to use, we can still demonstrate using algebra tiles. We simply shade when we're referring to positive numbers and leave the box unshaded when looking at negative numbers. Let's begin. In example 1, we will multiply x plus 4 times 2x plus 1. When using algebra tiles, we start by drawing a t-chart. Along one side of the chart, we fill in the factors x plus 4 using algebra tiles. X, the long green bar, and 4 single units, giving us x plus 4. Across the top, for 2x plus 1, we draw 2 green bars and a single unit. Our product is the result that occurs inside of our chart. When we multiply the terms outside.
Okay, I just want to reinforce the setup here. So we have x plus 4 times 2x plus 1, right? They introduced to you earlier that an x is represented with this, right? And then you have plus the 4 small tiles, right? And then when you have the 2x, so you have 2 of the bars plus 1 of the small tiles. Are we okay with that? So this is how they represent it. Okay, remember that what we're doing is we're doing multiplication. So now we're going to multiply.
X times x gives me x squared. X times x, x squared. X times 1, 1x. And we do this for the entire chart until there's no terms or blocks left. 1 times x, x. 1 times x, x. And 1 times 1. Which is 1. The bottom 3 lines are exactly the same as the line we just completed, leaving us x, x, and positive 1 all the way down. The solution are the tiles that remain inside this chart. As we can see here, we have 2x squared blocks, or 2x squared. We have 9 long green bars, or positive 9x. And 4 single units, which represents positive 4, giving us a final solution of 2x squared plus 9x plus 4.
So what they did here is they used, so from the two binomials multiplied together, right? When they multiply them together, they ended up with this final answer, which is 2x squared plus 9x plus 4. Okay, so this is the expanded form of the x plus 4 times 2x plus 1. Okay, what they did, they used algebra tiles. Okay, so do you understand where they got the 2x squared from? So you understand that this represents an x squared? Okay, so you have an x squared and an x squared. What does that give you? 2x squared. Do you understand how they got the x squared? So if you have x times x, what do you get? X times x, that is x squared. This is where they got the x squared from, right? X times x, that's where they got the x squared from, right? Then they did x times 1, so that's 1x. Okay, then they used this one here, and they did 1 times x. 1 times x is 1x. 1 times x is 1x. 1 times 1 is 1. Okay, same with this. That's going to be exactly the same thing as this because I'm multiplying exactly the same thing. 1 times x is 1x. 1 times x is 1x. 1 times 1 is 1. Right? And so on and so forth for the other two. Same thing. Are we okay with that? Now when it comes to the solution at the end, I have to collect my like terms or my like boxes or whatever, squares, rectangles. So you see that these two are like each other. So I have an x squared plus an x squared, that gives me 2x squared. Then I have x, 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 x. They're all like terms, right? I can add them all together. So I'll have 9x. This is where I get the 9x from. And then for these ones, they're single 1 units. There's no x in here. So 1 plus 1 plus 1 plus 1, that gives me plus 4. Do we understand that? No, this is one of the ways, and we don't usually use this one because it's a lot, like more. It's a visual form for people who likes visual things, okay? But at the same time, it's not the one that we're gonna use in the class, okay? Now they're gonna show another example with the negatives, just so you see what happens with the negatives.
Let's try a second example, only this time we'll include a negative number. Once again, we'll draw our T chart. On the left-hand side, we draw x plus 2. And across the top, we want to draw 3x minus 2. 3x, 1, 2, 3x bars. Now careful, with the negative, remember we want to draw the red bars. Multiplying, on the inside, we get x squared, a second x squared, and a third x squared. For the last two, just pay extra attention when you're working with negative signs. We have a positive times a negative, which gives us negative x. Positive x times a negative 1, another negative x.
So the first three are okay, right? Because x times x, x squared. X times x, x squared. X times x is x squared. Now, with the negative, this is where you have to be the extra careful, right? Where you have x, and then you're multiplying that x by a negative 1, right? And if you look at negative 1 times x, right, that gives you negative 1x, yes? Or negative x. That's why this turns to green, red, not green anymore. Okay?
Continuing down the line, positive 1 times x, positive x, positive x, positive x. And at the end, we have positive 1 times negative 1, which gives us negative 1 for both of these. The last line is exactly the same as the third. So we get x, 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 and two negatives. solution in this case, we see that we have 3x squared bars, or 3x squared. When it comes to the x bars, though, we notice that we have 6 positive x's, and we have 2 negative x's over here. When you have positive and negative of the same term, they're referred to as zero pairs, and in fact can be canceled. So we can cancel out this negative x and a positive x. This negative x and this positive x is another zero pair. We are then left with 4 positive x, and we write plus 4.
Are you okay with that? We all know that a positive and a negative, they cancel each other. Plus 1, minus 1, they cancel each other, right? You had a chocolate bar, you ate it, it becomes 0, right? Same here. So you have plus 1 bar, minus 1 bar, so they cancel each other. Plus 1, minus 1, cancel each other. You are left with only 4 x bars.
4x. Our final 4 blocks here gives us negative 4 for a final solution of 3x squared plus 4x minus 4.
So again, they started with 2 binomials multiplied with each other, and they ended up with a solution, what we call 3 terms. This is the expanded form, and 3 terms. What do we call 3 terms? Trinomial. Okay? A 3-term is called a trinomial. Okay? So again, this is what we call using the algebra tiles. We won't be doing that in here, but it's a good thing to see it if you have kids that are going to high school anytime soon, or that are in grade maybe 8, 9, right? You'll see them using this, or you'll see them drawing this. At least now you know, you've seen it. Okay? You know what they're doing. We have the same, we can also use what we call a chart model. So the chart model is similar to what we just did earlier. What is it called? To the algebra tile model, except I'm not using the tiles, I'm actually using the numbers that I have. Okay? So what you do, you can do a table like this, and then you can remember that I'm multiplying x plus 4 times 2x plus 1. So you can make the table, and then you can put x, and then you can put plus 4 in the second row, and then you can put 2x in the first column and 1 in the second column. Okay? So the x plus 4 comes from the first binomial, the 2x plus 1 comes in the second binomial. Are we okay with this? And then what we do, we multiply. Okay, so we're multiplying here. So remember that we're doing multiplication. So x times 2x, what do I get? 2x squared. Then I have x times 1, x. Pardon me? Are you guys okay with this up to now? Okay. Then we have 4 times 2x. What's 4 times 2x? You have 4 times 2. 8x. Guys, when you're multiplying x by x, this is when you get x squared. Right? In this case, there's no x. You have 4 times 2x. I should change my multiplication. 4 times 2x. Right? So you have 4 multiplied by 2, which gives you 8x. There's no other letters that you're multiplying here. Okay? Then you have 4 times 1, which is 4. Are we okay with this? Now, always we're going to have to look if we have like terms. Do I have any like terms? What are my like terms? 8x, oops. Oh, there you go. 8x and x. So these are my like terms. So then I would write my solution as 2x squared. What's 8x plus 1x? Plus 9 what? X plus 4. Okay? So all what I did for my last step is I collected my like terms. Because 8x plus 1x gives me 9x. Are we okay with that? Good. Remember that if it's x or just 1x, they're the same thing, right? Are we okay with that? So you have to be careful when you're multiplying and when you're adding. Don't get confused, okay? At first, you're multiplying to get your answers, and then at the end, you're adding the like terms. So you're adding the coefficients. Thumbs up from everyone? Good. Do you guys remember the distributive property that I talked about before? Do you remember the taco example? Yeah. The combo? Yeah. Remember I told you if you have 2 tacos in each combo and 1 pop, and you're a family of 3, remember? Then how many tacos and how many pop you're going to get? What did we say? You're going to get 6 tacos and 3 pops, right? And then we said that it's called the distributive property, right? Because you're multiplying the 3 by each term. Do we remember that from the review? And it's my famous, I told you it's my famous taco example. I keep it here. Okay. So we can use that distributive property with this. Again, these are all different methods. Whatever works for you, you can pick one and do it. I will be in the class, I'll be using the last one that I'm going to teach you today. But these are different methods that you guys can use. Like one semester I had students who preferred this one and they wanted to use it. I'm like, go ahead, use it. I won't be using it when I'm explaining. But if that works for you, perfect. Okay? So I'm going to be using the same kind of method here, but what happens is I have more than one term that multiplied by 2x plus 1. So I have 2x plus 1, which is similar to the 2 tacos plus 1 pop, right? So that's similar to this. But instead of only having 4 multiplied by it, I have x plus 4. So I'm going to have to use the distributive property twice. Okay? So that's the same thing as doing this times this whole thing and this times this whole thing. Okay? So I'm going to have this. X multiplied by 2x plus 1. And because I have plus 4 multiplied by the 2x plus 1. I think this is the most useless method ever because you're doing more work to yourself. Okay? But I'm just going to show it to you. What? Are we okay with this? Now let's do the distributive property as we did earlier. So x times 2x is 2x squared. X times 1, 1x. Then I'm going to move to the next one. So I have 4 times 2x. 4 times 1, 4. And then as you can see, I have my like terms in the middle. And I can add them to 9x plus 4. You see that no matter what method I'm using, I'm ending up with the same answer, and I should, otherwise I've done something wrong. Yeah?
Well, if there's no number at the front, like, it's automatically a 1? Or
That's correct. It's a 1. So if there's no number at the front, as I said earlier, right, you say you have an apple or 1 apple. It's the same thing, right? If I have an x or 1x is the same thing. So this here, automatically it's a 1x. Should be the first page. This is the homework.
the other booklet?
The one you give it.
Did you get 2 booklets?
No.
You got only 1 booklet? Okay, now let's look at the method that I will be using all the time, and the method is called FOIL. So you're gonna hear me refer to this method. When I say FOIL, you know what I'm talking about. Okay? So, FOIL is an acronym for the following. It's an acronym for first, outer, inner, last. Okay? So why do we call it first, outer, inner, last? So if you're looking at these 2 binomials, which one are your first terms? X and 2x. So from each bracket, x and 2x are your first terms. So that means you're going to multiply x by 2x. So x times 2x gives me 2x squared. Then you're going to look at, so again, remember it's FOIL. So you're going to look at your 2 outer terms in each bracket. Outer terms in each bracket, that means the ones are on the outside. And that takes me to the x times the 1. So these are my outer. Okay? X times 1, that gives me 1x. So you see that 2 arrows are coming out of my first term. Now, I'm going to look at my inner terms, so my 2 inner terms, the one that are inside, and I'm going to multiply them together. So that's 4 times 2x, which is 8x. And then my last, which is the last term in each bracket, first 4 times 1, which gives me 4. And that ends up being 2x squared. You're going to collect the like terms, which is the 1x plus 8x, so that gives me 9x, plus the 4. Okay? So I'll be using this method, first, outer, inner, last, or FOIL, right? Remember that at the end of the day, it doesn't matter which order you do them in, you're going to have 2 arrows coming out of the first term, and then 2 arrows coming out of the second term to the next bracket. Okay? So, here's what you're going to do. You're going to practice example 1. Okay? So you're going to do these. Before we get to this point right here, we're going to look at C and D quickly. What does it mean when I have 6x plus 1 all squared? Write the same thing twice, right? Remember that before we said that if I have x squared, that's the same thing as x times x, right? Same thing here, because I have 6x plus 1 squared, that's the same thing as writing 6x plus 1 times 6x plus 1. Okay? So now you have 2 binomials, so you can do the FOIL. We're good with that? So I want you guys to practice this, and then make sure that you check your answer with the person sitting next to you.